Hello and welcome to today's video. In today's video, we are going to learn about equations. So equations in chemistry can be categorized into two. We have what we call word equations and we have what we call chemical equations. So what is a word equation? So a word equation is just an expression of what is happening in a reaction using words. So we use words to describe what is happening in a chemical reaction. In contrast, a chemical equation is now we describe what is happening in a chemical reaction using chemical symbols. So that is the only difference. For a word equation, we use words. For a chemical equation, we use chemical symbols. Let's look at a general equation. So for a general equation, we're going to look at A plus B producing C and D. So depending on where the arrow is pointing, this means that these are your reactants. Then what is being produced are known as products. Then we have a positive this side. A positive means reacts with. Then the arrow means to produce. Then on the product side, the positive in this case means and. So if I'm going to make an interpretation of what is happening here, I can simply say A reacts with B to produce C and D. That is the interpretation of what is happening here. Let's quickly go into examples of word equations. So remember, for word equations, we're just using words, but obviously sticking to this general equation. For example, we say magnesium reacts with oxygen to produce magnesium oxide. So if I am to write a word equation for this, I just need to understand the terminology. What does reacts with mean? What does to produce mean? So this will be written as magnesium. So reacts with means plus oxygen. Then to produce means arrow. Then magnesium oxide. The common example is the reaction of photosynthesis, where we say carbon carbon dioxide reacts with water to produce glucose and oxygen in the presence of sunlight and chlorophyll. So this equation is obviously written as follows. So we know that it's carbon dioxide plus water, then this in the presence of sunlight and chlorophyll. Chlorophyll, this produces glucose plus oxygen. So here, what is happening is we're just using words to describe what is happening in that particular reaction. Let me give one last example. 3, we use calcium carbonate decomposes thermally. So it's a thermal decomposition thermally to produce calcium oxide and carbon dioxide. So to write this as a word equation, so this means calcium carbonate, so decomposes. So thermally we use this to represent heat. So it's a thermal decomposition, meaning it's subjected to heat, and then calcium carbonate, so decomposes thermally to produce. So there's calcium oxide plus carbon dioxide. So I'm not going to go into the types of reactions. So those are some of the things that you can look at, types of reactions, as a side note. So we have what we call synthesis reaction, we have neutralization reaction. We can look at this in a separate lesson. We have double decomposition reaction, we have precipitation reaction, we have, which one have I left out? Synthesis, neutralization, double decomposition, precipitation. We have what we call displacement reactions. So we can take time to look at those in a separate lesson. Now, for now, I want us to quickly go to chemical equations. So chemical equations. So remember, for chemical equations now, we're using chemical symbols. We're using chemical symbols. I would just like to state that I'll put this as a note. So whenever we are dealing with chemical equations, so the following exist as diatomics. I'll explain diatomics in chemical equations. Okay, so oxygen, whenever you're writing oxygen, you write it as O2, O subscript 2. Whenever you are writing nitrogen, you write it as N2. So oxygen, nitrogen, and hydrogen, you write them as diatomics. Then all group 7 elements, so halogens. So all the halogens are also written as diatomics. So we're looking at fluorine is written as F2, chlorine Cl2, bromine Br2, iodine or iodine, so astatine. So all these are written as diatomics. Let's look at the general equations that we are going to follow. So these are the general chemical equations we'll use as examples. The first one will be a reaction of a metal plus oxygen, which will give us a metal oxide. Let's look at examples. So a reaction of a metal to produce, a reaction of a metal and oxygen to produce a metal oxide. For example, they say magnesium reacts with oxygen to produce magnesium oxide. So this is a word equation. Now they want us to write a chemical equation of this. So what we need to understand is magnesium reacting with oxygen. Remember, oxygen is written as a diatomic to produce magnesium oxide, which is a compound. So what is magnesium? Magnesium is capital M small g plus. Remember, oxygen exists as O2 to produce. So what is magnesium oxide? So you go back to chemical formulas. So you're combining magnesium and oxygen. The valence number of magnesium is 2. The valence number of oxygen is 2. Equivalences, they cancel. It is MgO. So that is MgO. So this is magnesium oxide. This will be called a chemical equation. So remember, we are looking at the reaction of a metal and oxygen. So think of any metal. Think of any metal. Let's say potassium. Potassium reacts with oxygen. Then this definitely will give us potassium oxide. So how do we write the formula? So what is potassium? So we know potassium is capital K plus. What is oxygen? Oxygen is O2. How do we write potassium oxide? So we are combining potassium, valence number 1, oxygen, valence number 2. When we interchange, we get potassium oxide. So K2O. So that is the chemical equation. Let's move away from this and look at another set of the general equation, which is 2. So let's look at the reaction of a metal plus water, which produces a metal hydroxide plus hydrogen gas. So a reaction of a metal and water produces a metal hydroxide, and hydrogen gas. So what does metal hydroxide mean? So metal hydroxide means metal combined with hydroxide, which is a radical. Let's look at an example. We'll use the same example that we looked at in the previous slide, where we say A, now magnesium combines with water to produce. So what is going to be produced will be called a metal hydroxide. What is the metal? The metal is magnesium. So it's going to be called magnesium hydroxide plus hydrogen gas. So to write the chemical equation of this, so what is magnesium? Magnesium is capital Mg plus what is water? So H2O. H2O with a state symbol. So I will talk about state symbols soon. So a state symbol L. So state symbol L represents water. State symbol G represents steam. I will talk about this very soon. So how do we write magnesium hydroxide? So magnesium hydroxide, remember, you are combining magnesium and hydroxide. The valence number of magnesium is 2. The valence number of hydroxide is 1. So when we interchange, it becomes Mg. 2 is going to a radical, so we put a radical in brackets, then 2. So this is magnesium hydroxide. So MgOH2 plus hydrogen. Remember, hydrogen is part of these that we mentioned. So we write hydrogen as diatomic. So plus H2. So that is the chemical equation. I would like us to look at another example. Let's look at the same example that we looked at, potassium. So potassium plus water. So what are we going to get? So metal hydroxide. So what is the name of the metal? It's potassium. So it's going to be potassium, then hydroxide. So it's potassium hydroxide plus hydrogen gas. What is potassium? So potassium is capital K plus what is water? H2O with L as a state symbol. I'll talk about the state symbol soon. What is potassium hydroxide? So you're combining potassium with the valence number 1, hydroxide with the valence number 1. Equivalences, they'll cancel. So it'll be KOH. So this requires you to have a very good, then hydrogen H2. This requires you to have a very good foundation in the languages of chemistry. So know how to write chemical formulas. Then the writing of chemical equations becomes very easy. Let's look at another example of a general equation. Metal plus steam. This produces metal oxide plus hydrogen gas. So steam is just H2O but using gas. Remember, water is H2O but the state symbol is L. So this means water. When we see a state symbol G, there means that you're dealing with steam. It's vapor. Let's look at an example. The same example that we looked at. magnesium plus steam. So it's a metal oxide. So what is the name of the metal? So it's called magnesium oxide plus hydrogen gas. Let's write the chemical equation. What is magnesium? Capital M, small g. What is steam? H2O with a state symbol G. What is magnesium oxide? So magnesium oxide, you're combining magnesium and oxygen. The valence number is 2, the valence number is 2. Equivalences will cancel. So it's MgO. So MgO plus, what is hydrogen? Hydrogen exists as a diatomic. So that is what we'll get. Let's look at another example now using potassium. Potassium plus steam. This will produce a metal oxide. So a metal oxide will be called potassium oxide plus hydrogen gas. So you can pause the video and try to work it out. So what is potassium? So potassium is capital K. What is steam? H2O gas. So what is potassium oxide? So potassium oxide means I'm combining potassium and oxygen. Valence number of potassium is 1. Valence number of oxygen is 2. When I interchange, I'll get K2O. So K2O plus H2. So that is the chemical equation. Let's look at the last one. The last one will be called the metal plus halogen. So halogen, these are group 7 elements on the periodic table. So this produces what we call a metal halide. A metal halide. Let's look at an example. I'll use magnesium again. So magnesium plus halogen, so group 7, let's use fluorine. Fluorine. So this will produce metal halide. So metal halide meaning magnesium. So this becomes fluoride. So it's just the IDE that changes. So we're not going to say magnesium fluorine. So it becomes magnesium fluoride, magnesium chloride, magnesium bromide, magnesium iodide, magnesium acetate. So if we're going to write the chemical equation here, we know that magnesium is capital M, small g, plus fluorine. Remember, these are written as diatomics, so it's going to be F2. What will be the product? So we combine. To get the product, you have to combine magnesium and fluorine. Valence number of magnesium is 2. Valence number of fluorine is 1. When we interchange, it becomes MgF2. So this will be MgF2. Let's look at another one using potassium. So potassium plus, let's use bromine, reacts with bromine to produce. So what will be produced will be called potassium bromide. Potassium bromide. Then we're going to write the chemical equation. This, what is potassium is K. What is bromine? Remember, they exist as diatomics, so subscript. Then if we combine, we're combining potassium and bromine. Valence number is 1. Valence number is 1. Equivalences will cancel. So KBr. So it's going to be KBr. So that is the equation that we are going to get. Let me leave you with questions that you can try. So you can write the chemical equation of this and you post in the comment section. So lithium plus oxygen to produce lithium oxide, calcium plus water to produce calcium hydroxide plus hydrogen gas. We can also look at rubidium plus steam, giving us rubidium oxide plus hydrogen gas. And the last one, we can look at barium plus chlorine to produce barium chloride. So you can try to work out those and post the answers in the comment section. See you in the next video.